All right, so another nifty example. So now that we figured out how many protons are in aluminum, which is 13 if you remember, we figured out how many neutrons are in aluminum, which is 14. We want to know how many electrons are in it. Of course, we have to figure out every piece of this atom. So, aluminum is a neutral atom, so that means the number of electrons equals the number of protons. So if we have 13 protons, that must mean we have 13 electrons. So you may be wondering how I know if the atom is neutral or not. If we have an atom that is not neutral, it's going to have a charge indication up in the top hand corner right after its symbol. So these are not neutral atoms. If you look at what I've written up here, there is no charge indication, so that means it is a neutral atom. It has 0 charge. All right, so now we're going to move on to the fun part of drawing these models. Some important information that you do need to know: the energy levels. This is the most likely, in quotes, because remember, we have stated that energy levels are not necessarily there. This is the most likely location of the electron in the electron cloud. And the max number of electrons in each level is stated below. So the first level will have 2, the second will have 8, third 18, and fourth 32. So these electrons, they are super duper happy when they have full electron shells. So when level 1 has 2 electrons in it, when level 2 has 8 electrons, when level 3 has 18, and so on. So we would not have a situation where level 1 has 1 electron and level 2 has 8 electrons and level 3 has 3 electrons. That would not be the case because this first level is not full. So that means that first level is not happy. There are always exceptions to the rule, but for right now we aren't going to discuss those exceptions because they're not terribly important, or they're not going to pop up for right now. So I do have a picture here that kind of shows what I am looking for when it comes to showing the electrons. The only difference here is that I am going to have you write the little E- afterwards to show that these are electrons. I apologize for the blank screen there for a second. Because otherwise, if I didn't know that this little thing right here was the nucleus, I may think these are protons. So we're going to label everything. That is a big thing in science. Label, label, label. All right, so let's try some. So make sure you have your periodic tables handy. And let's take a go at this first one. So the first model we want to make is sodium. So the atomic symbol for sodium is Na. Make sure that we write that down so that we know what this model is, what the atom is. Okay, and so now we need to know how many protons are in it. Well, the atomic number is 11, so that must mean that we have 11 protons. Okay, and now neutrons. The mass number is 22.9. I'm going to round that to 23. So that means we've got 12 neutrons. Remember, you subtract the mass. 23 minus 11, the mass minus the atomic number to give you the protons, or the neutrons, I apologize. All right, so now I put a big circle around that because this right here is my nucleus. do not forget the nucleus. It is very important. All right, so now let's start filling in these electrons. Sodium, as you see, there is no charge right here, so that means it's a neutral atom. So we need to put 11 electrons in here. What I'm going to do is I'm going to write down how many electrons I have up at the top, and then I'm going to, as I use them in the energy levels, I'm going to start crossing them out so I know how many I have left. So in the first level, we're going to put 2 electrons because the first level can only hold 2 electrons. Okay, so 11 minus 2, I have 9 electrons left. All right, well, guess we got to fill another energy level. All right, the second level can only hold 8 electrons, so I'm going to fill that baby up. 8, all right, we still have 1 electron left. Okay, so we've got to put a third one in. All right, now we have our sodium atom. Looks like it's all done. So the important thing is don't forget to label. Make sure that you are identifying and putting in the right number of electrons in each energy level. So the max number is as high as these energy levels can go. So the first energy level can have anywhere between 1 and 2 electrons. The second can have anywhere between 1 and 8 electrons. The third, anywhere between 1 and 18. So it doesn't mean that it can't have less than its max number, but it cannot go over that. So this one, we couldn't have put all 9 electrons right here because the max number is 8. All right, let's try one more. So now we're gonna do phosphorus. Phosphorus, its atomic symbol is P. And now we need to know protons. Protons equal the atomic number. The atomic number is 15. So that means we have 15 protons. All right, my atomic mass is 30.9. Gonna round that up to 31. Subtract the atomic number. All right, so I have 16 neutrons. All right, cannot forget my nucleus. That is very, very important. Okay, now we gotta fill in the electrons because that's the only piece we're missing. No charge here means we have a neutral atom, so that must mean that the electrons equal the protons. All right, let's start filling this in. First level, remember, can only fit 2 electrons, so we're going to put 2 electrons here. Okay, we've used 2 electrons, we have 13 left. The second level can fit 8 electrons, so we're going to fill that baby up. So now we have 3 electrons left. All right, looks like we can just throw those 3 electrons in the very third energy level here. Now we have our atom. So key points from this lesson: protons equal atomic number. Electrons in a neutral atom equal your protons. To figure out your neutrons, you're going to subtract the atomic mass from the atomic number. And label, label, label. Make sure you're labeling every piece of this atom so that we know which numbers are which. Sometimes there could be 15 and 15 protons and neutrons, so I wouldn't know which one was which. This way we don't lose track of anything and we know where we're at. All right, this sums up the parts of an atom lesson. I hope you have a great day.